So this is the answers to the 2.1 matter booklet. This will be the whole of the double booklet and then the start of the triple booklet. So you've got that, and it'll be in a lot of a nicer kind of look with your knowledge organiser and bits that you can zoom in on. You've also got your keywords that you can use. And then the first bit is the answers to the kind of core knowledge questions. I'm not going to completely run through these, but it might be worth pausing and having a look. So I'll do that first for you. Pausing and having a little look at each bit. Okay, particular focus to things like the moles and ionic formula, because they're likely to be kind of the harder questions that you might come across in the exam. So again, with the review sheet, I'll just zoom in. I'm not going to talk through each bit individually, just because these are things that are what we call core knowledge, and you should be able to understand, and that means that you can kind of just pause as and when you need it. Okay, so just some examples of solids, liquids and gases, different changes of state, which will be a nice easy question, some calculating MR, looking at mass numbers, PAN, and then there's some chemical formula practice and some moles practice as well. But like I said, you can kind of pause, zoom in as and when. So the first main question, and you will get a question like this quite often in the exam. The first thing I always do when I see a question like this is the melting point is how something turns from a solid to a liquid, and then boiling point is how something turns from a liquid to a gas. So you've kind of got that to help you. At that temperature, Y turns from a solid to a liquid. At this temperature, it turns from a liquid to a gas. So a substance which is gas at room temperature is around 25 degrees. So being a gas will have numbers both below 25, so it would be Z. Some of the liquid at room temperature, both W and X, have already melted and turned into a liquid, but they haven't reached at 25 degrees their point to turn into a gas. A temperature which is solid at room temperature, Y, these numbers are so big that it's at no point is even turned into a liquid. Which of the substances from the table is pure water? X, because they are the boiling points and melting points of water. How do you know that? Because water boils at 100 degrees, so it means it turns into a gas, and water freezes at 0. Okay, so the first one says, describe, if any, trend, the melting point. So again, the melting point is the dark shaded in, the black bar, and you can see that as you go down the group, because fluorine's at the top, so fluorine's at the top, acetine's at the bottom, you can see how it increases down the group, it gets higher. Which element has the lowest melting point? Even though it's a big number, it's a minus, so it means that's the lowest. Used to predict, so I've drawn some trend lines on here. This is quite hard, and I've drawn on where. So I've drawn a trend line through the black ones to give you the melting point, and then I've drawn another trend line through to give you the boiling point. Which element is a liquid at 70? Okay, so remember, think about it again, this is really important. When you're melting, you turn from a solid to a liquid. When you're boiling, you turn from a liquid to a gas. So you're looking for something that has already melted below, but hasn't turned into a gas yet. Next question, really nice question. You even got given some of the words. So part X, they're the electrons. What's the part in the Y? That's the nucleus. The nucleus contains the protons and the neutrons. Again, a nice easy question here. Labelling up bits. So neutrons are neutral, protons are positive, electrons are negative. Next little bit then, if you wanted to, you could have labelled that mass and then that atomic, just to help you. The mass number is the number of protons plus neutrons. The atomic number is the number of protons, which is equal to the number of electrons. So beryllium has 4 protons. Use the small number. Atomic number is 4. Mass number is 9. Neutrons, you do the mass number, take away the atomic number. Moving on then to elements, compounds and mixtures. Okay. So which one's a compound? It's got 2 or more different elements joined together. So it's going to be that one. A molecule of an element, an atom, so a single one on its own, and then a mixture different ones, but mixture of two elements, because you can see in the actual molecule, they're the same. Again, some diagrams now. A compound, A, because it's two or more different ones combined. A gaseous element, so something D, because they're moving around. And an alloy, potentially might not have done a lot of that. Alloys are two metals that aren't. So this would be a metal, a complete metal. And then the one above there is an alloy because of the way it's spaced. Lots of different elements here, or not elements, just compounds, molecules. So a compound would be that one because it's two different elements joined together. An ion, or metal ion, sorry, so it has to have a positive. If it's a metal, it must be positive. State which diagram represents an element. Again, very similar question. So it's going to be D because they're same type of element, same type joined together. Which one represents carbon dioxide? So carbon, one carbon, two of them. So it has to be A. Give the formula of diagram C. So we've got 1, 2, 3, 4, 5, 6 hydrogens, and we've got 1, 2 carbons. Write a word equation for the reaction taking place. So copper sulfate reacts with sodium hydroxide to form copper hydroxide and sodium sulfate. Nice, easy question. Number of sulfur atoms, there's only one. Remember, if there's no little number, it's one. Total number of atoms in here. Remember with this, imagine, I'll zoom in a little bit. Imagine there's little ones by there. So you've got two of them because you times by 2 and one of that. They've given you a key and then they've asked you to draw it. So again, a nice easy question. Oxygen in the middle and then nitrogens on either side. Give the chemical formula. So you've got 1 nitrogen in the middle there and then 3 hydrogens. And then quite a question quite similar to what we've just done when they've given you gases. So the elements are the ones on their own. So you've got an oxygen's on it, so it's just oxygen. Compounds then anything with 2 different combined. How many nitrogen atoms are in the formula? 1. Total number again, something we've just looked at. This would be 1, 1, 3. This question you can kind of expect to come up as well. Which particles or atoms? Explain your choice, okay? So to be an atom, you need the same number of protons as you do electrons. That's much the easiest way to do it. So A, D, and E all have the same number of protons as they do electrons. Which ones are positive ions, okay? Now remember, protons are positive, electrons are negative, neutrons are neutral. So to be positive, you need to have 1 more proton, or 2 more, okay, than you do electrons. So you're expecting a higher number here than you are here. So we've got B and F, okay? Because this one, if you look for F, 2 more, so it's 2 plus. What is meant by an isotope? You need to learn this definition. It needs to be in your brains. Learn. Same atomic number, different mass number. Same number of protons, different number of neutrons. Very similar again. You can see the questions are quite repetitive. Which one's an element? It has to be C because it's the only one with two of the same. Which one represents SO2? So that's because the easiest way to do it is you're looking for 3, but you've got 2 oxygens the same, so it has to be D. Which one represents water? Now remember, with water, you need to have the one in the middle, so it can't be that one, can't be that one. If you use this one up here to help, you know the oxygen's that big circle. Relative formula mass. So I've got 1 hydrogen, 1 chlorine, 1 oxygen. Nice, easy. Add them all together. Relative formula mass of sulfur dioxide. They've given you the formula. So, they've given you the MR, sorry. They've given you the MR there, and they want to work out how much sulfur. So you do the total of sulfur over the whole total. And then final question is a moles question. Okay, first off, they gave you the MR of sodium carbonate, and then they said how many moles if you've got 5.23. So you do the mass over MR. Remember, think of your equation, a mass standing over a Mr. mole. Cover at mole, because that's what we want. So we're going to do mass over MR. They've given you the MR, they've given you the mass. They've then gone on to say calculate the number of moles. With this one though, they didn't give you the MR. So that's what I've done there as my first bit, is I've worked out the MR and then I've done the mass, which they gave me, over the MR. Final question then, again, very similar. They haven't given you the MR, so that's what I've worked out here, but they have given you the mass. So again, I've done the mass over the MR.